Well, very exciting. It looks like my spindle's going to be here in just a few minutes. Ah, it's cool. So, I've got a box. It's the new spindle, the air-cooled spindle, and this is what I've been waiting on. So now we could wire it up and test it out. I'm very excited about that. Cool. Hey there. So, as you can see, we're out in the shop. All right, and you can see that I have the spindle removed from the machine. Okay, this cable connector is slightly different than the one on either of the two new mills, so I'll have to take it off and solder on the connections to one of the new ones, but that's not a big deal. Other than that, it's just a matter of dropping it in and tightening these up. It's mounted. But let's go take a look at them. I've got them sitting over here. This is the original spindle from Laguna, water cooled. All right, and I don't know whether you can see it or not, but this has a ER11 collet on it. That's the same size as my little Frankenlab. All right, even though it's a 2.2 kilowatt. This one is the water cooled. It's got an ER20 collet, and the ER20 collet, and I can show it to you better on this one because the styrofoam's a little broken out. It's a much larger size, and this one can take anywhere from a 1/16 of an inch, about 1 millimeter, all the way up to a 1/2 an inch, which is about 12 millimeters. So that gives me an incredible range as far as tools go. You can also see that when we look at this spindle and compare it with the original, this is much longer. It's also a little bit heavier, and I had some concerns as to whether that could drive it or not. All right, but because these ferrules are an odd size, they'll accept the vinyl tubing, but I wanted to use a polycarbonate, and I wanted to use those quick plug-in connectors in case I had a leak. I could fix it quick, and I can't find an easy solution to get that to work. I also found out that the pump is seized up, so that's another $150 to $200 for a new pump. So it'd be a lot less expensive for me to go with this one, which is the air-cooled. And if you look, the air-cooled, the new one, and the old one are almost identical in size. And this one is possibly just a hair lighter. I haven't put it on a scale to weigh it. So it should be good. The only concern I have is how noisy is it going to be? And it's got some vents here where air gets pulled up and exhausted out here for cooling. And I'm going to have to make sure that these are kept clear of any kind of dust or anything. Periodically blow it out with the air compressor. But I don't think that maintenance is going to be too bad. So my next step is to wire it up, test it out, and see what happens. Okay. We need to get these wires on. And I need to put a little bit of heat shrink tubing on this first wire. And I've got to verify that should be the U wire. So I'll take my digital multimeter here and set it up. And then when I connect to this wire here and I test these out, see, nothing, nothing, and beep. So this wire is marked as U. So that one goes on to the U connection, and when I look on here, the U should be number 1. So that should be this one here. So that's where I need to connect that wire to. So first, I'm going to put a little bit of solder on this wire, make sure that I got all my wires going in the same direction. Like that. Pre-solder it. It'll get it nice and wet there. That's good. And then come down to this connector and put a little bit of solder onto this connector here. Just like that. Then I hate doing this left-handed. I got to get this on here. Let's see. No, I don't have much extra wire to play with. Wait. Ta-da! There we go. That'll work. Yay. Improvise. It's nice and wet. Let it liquefy really well. Get this wire down into that. There we go. Let it cool for a minute or two. There. And then I can slip this heat shrink down over it. There we go, see? Now it's not going to accidentally short on anything. Got 2 more to do, and then I'll be ready to close up that connector. Okay. We've got the spindle connector on, and this is the other end of it. So I've got to put this into the electrical box and hook it up. Okay, boys and girls. I have 220 volts into the machine live. Hopefully when I flip this switch, I don't see any sparks. We got a fan running. We got a VFD showing power. Spindle's not doing anything. All right, there's a button over here. If I push it, yeah, I'm not seeing anything, but I might have other wires in the VFD to hook up. So I'll have to read the manual. RTFM. Read the freaking manual. All right, but I got power, so hey, I'll take that, right? Yay.
That's true. Got power and no sparks, so that's good.
That's right, Terry. Got power and no sparks. Say hello to YouTube.
Hi, YouTube.
Okay, so the next thing I want to do is, I know that I've got basic power here. I got to see if these 2 power supplies are good. So I'm going to turn it on, and out of this one I should be measuring 24 volts. And then this one I believe is either a 40 or a 60 volt unit. So that's the power for the motors, and I can check it at any one of these points. So the next step is for me to turn power on. Got power on. I got my meter. So we'll come over here. I'm on DC. And let's see if I can do this. Come on, get over here. Yeah. Right here and here. Not seeing it. Of course, it's a switching power supply. It may need to have a load on it. Let's try it again. Let's see. What do we got here? We got butt kiss. We got 0.2 volts. Alright, this thing probably needs a load on it. Alright, let's see what I got for these. That could be 24 volts AC though. Alright, 39.9 volts DC. So these are working. These are ready to go. This could be an AC. Let's try it in AC mode. See what I got there. It could be 24 volts AC. I was hoping for a DC power supply, because that's what I would use for my my sensors. But I can pull that power supply out and use it for something else. Let's see. And I'm still showing nothing there. Let's go back to DC. Yeah, 0.2 volts. I don't know what's going on with that power supply. But it was used for the old board and we're not really using it. So I can pull it out and put a different power supply in there for my sensors. That's not a problem. Or I could actually pull it out and use that to mount my my other board, either the Mesa board or the other one. But the 220 volts links in and goes through it. and I can verify that. Set that on AC and then come in here. Be very careful not to touch the wrong thing. That would be bad. 249 volts, yeah. So I got good power. I know this is running, that was major. This, I don't know exactly what's going on with it, but that was for the old board. And maybe it died. Maybe that's why the old board died. I don't know. But all I need for my sensors is 12 to 24 volts, and I've got an extra power supply for that. I can take that out and mount it in there. Although this is a 220 and the one I've got's 110. I'll have to look. I'll have to figure that out. But still, it's not a big deal. We're good. The most expensive components are this and this and these, and they're all functional, it looks like. So that's good. For these, all I need to do is put in step and direction, step and direction, step and direction, which are these three wires here, and the 4 connections for each of the X, Y, and Z stepper motors. And I should be able to get this mill running. So the big thing's going to be, can I fiddle with this thing and get the spindle going? I was hoping to get that tonight, but I'm not going to push my luck. All right. We'll see what happens on the next volley.